This is Jacques Charles in the picture, and he was a scientist that studied gas laws. And when he looked at gas laws, a lot like Boyle, he held one variable constant. So Boyle's law held temperature constant. Boyle looked at the relationship between the pressure and the volume, and he figured out that if one goes up, the other one goes down, and they always do the opposite. Charles looked at the gases as well, but when Charles, oh, my picture went away, sorry. When Charles looked at the gas laws, he actually looked at volume versus temperature. So if we go back to our PTV card, he is going to hold pressure constant. And he's going to look at the relationship between volume and temperature. And when he looked at the relationship between volume and temperature, holding the pressure constant, holding the pressure constant, he figured out that these are a direct relationship. So Boyle's law, when he held temperature constant, figured out that if one goes up, the other one goes down, or the opposite, if one goes down, the other one goes up. Charles actually figured out that these are a direct relationship, which means that if I'm holding my pressure constant, if temperature increases, so does my volume. If my temperature decreases, so does my volume. And that kind of makes sense because if the particles are moving faster, they're going to take up more space. If the particles are moving slower, they're going to get closer together. Eventually, they're going to get close enough together that they're eventually going to turn into a liquid, but we're only talking about gases right now. So your volume and your temperature are related to one another. It is a direct relationship. If one goes up, the other one goes up at the same rate, which also means that it's a proportion. So when we're doing these math problems, you're going to see a proportion type value, and they're both going to go up at the same rate or they're going to go down at the same rate. So as we look at the math here, again, we're going to get three variables. You're going to have volume 1 and temperature 1. You're going to change one of those variables, and you're going to have a new volume or a new temperature, depending on what you change overall. So you're going to see how the other one reacts. So when we look at this equation, we have V1 over T1, volume 1 over temperature 1. Remember, the ones are where you're starting. It's like your baseline. Then you're going to set that equal to, it's a proportion, so equal to volume 2, your new volume, over your new temperature. So V1 over T1 is equal to V2 over T2. When we look at these, you always have to use the correct units. And we said at the beginning of this unit, anytime you have pressure, you have to use ATM. But we don't have pressure in this one, so we're going to ignore pressure. Anytime we have temperature, we have to use Kelvin. And that's because the relationship overall, when you look at it, V1 over T1, if you plugged in a negative temperature on any of those values, you would end up with a negative volume. And you can have negative values on the Celsius scale. There is no such thing as a negative value on the Kelvin scale because 0 Kelvin is the lowest possible temperature. So whatever is given to you in Celsius, you're going to have to convert it to Kelvin. And the equation that I gave you at the beginning of the year when we did these is Celsius plus 273. So what that means for sig figs is whenever you have your Celsius plus 273, because you're adding to a whole number, your answer for Kelvin is always a whole number. Because sig fig wise, you always have that whole number that determines your value for your answer. So I have, again, my document camera here. And with my document camera, I also have my calculator. So I'm going to switch that over real quick. And my problem here says a balloon occupies 4,300 milliliters at 77.25 degrees Celsius. What is the volume of gas at negative 23.4 degrees Celsius? So what I know is V1 over T1 is equal to V2 over T2. This is what I'm starting with. This is my new values. I also know that my temperature, I'm going to have to use Kelvin. My volume, I have to use liters, so I need to make sure that I convert it out so I have those correct units. 1 liter is equal to 1,000 milliliters, And then your Kelvin is equal to Celsius plus 273. I shouldn't need any other information other than those things up at the top. So this says a balloon occupies 4,300 milliliters at 77.25 degrees Celsius. So this is what I'm starting with. So this is volume 1. This is temperature 1. What is the volume of gas? So I don't know my new volume. At negative 23.4 degrees Celsius. So that's my new temperature. So I know my variables that I'm going to plug into my equation up here. I need to make sure that I have the correct units. When I check to make sure that I have the correct units, I have to have liters and I have to have Kelvin. This is milliliters. So in order to go from milliliters to liters, I need to divide by 1,000, or I'm going to move my decimal place 1, 2, 3 times. Before the move, I had 2 sig figs. So I need 2 sig figs here. So that's 4.3 liters. 77.25 degrees Celsius needs to go to Kelvin. So we have 77.25 plus 273. I'm going to round this to be a whole number. When I round that to be a whole number, it ends in a 0 when I'm adding. So I'm going to put 350 with a decimal place at the end to rescue out those sig figs. I don't know my new volume, and then this one is negative 23.4 plus 273. This one, again, it needs to go to a whole number, so 249.6 is actually going to go to 250 Kelvin. So now that I have all of the correct units, I have everything that I need to plug in, I'm just going to plug in my values. 4.3 over 350 is equal to V2 over 250. I need to get V2 all by itself. To get V2 all by itself, we have to cross multiply, just to remind you on how to do this. So I'm going to take 4.3 times 250 is equal to 350 times V2. So to get V2 all by itself, I'm going to divide by 350. Divided on both sides. So now, in order to do the math here, I'm going to pick up my calculator and I'm going to do 4.3 times 250 divided by 350. My calculator says 3.07. I have 2 sig figs, 3 sig figs, 3 sig figs, so this needs to go to 2 sig figs. So I get 3.1, because the 7 makes the 0 go up. And then my volume is always in liters. Volume is always liters, temperature is always Kelvin. To see if that answer makes sense, my temperature decreases. It starts at 350, it goes to 250. If I hold my pressure constant and I look at my PTV card, my temperature went down, so did my volume, so that made sense. It started at 4.3 and now it's at 3.1. To show you a second example, it says a 3-liter sample of a gas has a temperature that is lowered from 80 degrees to 30 degrees Celsius. What is the new volume? So again, we're solving for V2. You don't always solve for V2, but for some reason, both of these examples that I picked, both solve for V2. It says that I'm starting with a 3-liter sample, so that's V1. And the temperature is lowered from 80, so that's my first temperature, to 30. So I have V1, I have V2, I have T1, I have T2. I need to check to make sure that my units are all correct. I have liters, which is right. But here I have Celsius, that needs to go to Kelvin. So to go from Celsius to Kelvin, we're going to take 80 plus 273. This one is 353 Kelvin. And then 30 plus 273. Shouldn't need a calculator for that one, but that is okay. Just showing you where I'm getting my answers. And that's 303 Kelvin. So now that I have everything that I need, all the units are correct, now I'm going to plug it in. V1 over T1 is equal to V2, I'm solving for that one, over T2. Again, I'm going to cross multiply. 3.00 times 303 is equal to 353 times V2. I'm going to divide both sides by 353 to get that to cancel, move it to over. So now I just need to get my calculator to solve for V2. So here I'm going to take 3 times 303 divided by 353. Here I have 3 sig figs, 3 sig figs, 3 sig figs. So my answer is going to have 3 sig figs, 2.58. I'm solving for volume, so my unit is liters. Again, if we look at our PTV card, my temperature decreased. So if my temperature decreases, so does my volume, which makes sense because I have 3 here and it went down to 2.58. I hope that helps. Like I said, these are just proportions, so it should be pretty simple math. Usually the hardest part is figuring out which value is which, but still, you guys being in pre-AP usually get that pretty quick. If you guys have any questions, make sure that you ask. Otherwise, have a great day.